Alright gang, section 4.1 is about finding and interpreting slopes of lines. Slopes, or I guess just slope. Slope pretty much just refers to a line and its like steepness, how steep the line is. And it says right here we are going to be using line graphs that look like one of the following four pictures. So four basic scenarios. In the first scenario we have an uphill line. In scenario 2 we have a downhill line. In the third scenario we have a perfectly horizontal line. And in the fourth and final scenario we have a perfectly vertical line. Okay? And ultimately, if the line is like an uphill line, that means its slope is positive. If the line is downhill at all, that means it's a negative slope. If the line is perfectly horizontal, that means that the slope is exactly equal to 0. And if we have a perfectly vertical line, that means that we have what's known as no slope, which means the slope is undefined. The slope doesn't technically exist. All right? So again, a positive slope means an uphill line from like left to right. Negative slope means like a downhill type thing. Makes sense. Horizontal line, the slope is exactly equal to the number 0. And if the line is vertical, that means there like is no slope even to talk about. We will explain how steep the slope is by writing the slope as a positive or negative fraction. So, in order to discuss how steep a line is, in other words, the slope of a line, it all basically boils down to a comparison between how much rise there is, like how much we go up or down, compared with how far we go forward or whatever, okay? So it's a ratio of like vertical change compared with horizontal change. And so most of the time, and again, the variable is m, and you'll hear a lot, if you haven't already heard this a lot over your lifetime. Slope is a fraction where it's about the rise over the run. Again, it's like how much you go up or down compared with right or left. Let's see some examples of that. Find the slopes by counting. Well, first we need to pick some nice points to kind of count from and to end at, okay? So I see this as a nice intersection spot, and maybe that as a nice intersection spot. So as far as like to count, it's best to find like nice points of intersection. So right here and right here. And so starting from this dot, I'm going to count how much it rises and then how much it runs to get from here to here. And so here we go. We're going to rise and we're going to go up. 1, 2, 3, 4. And going up is a positive direction. And so my rise is going to be positive 4. Again, 1, 2, 3, 4. And then my run is going to be to the right. I'm going to go to the right, 1, 2. And going to the right, do you think going to the right is a positive or negative direction? It's positive direction. So my overall slope, rise over run, is positive 4 over positive 2, which is going to ultimately equal positive 2 over 1, or just 2. So m equals 2 is the final answer. Example 2. I see this as a nice spot to start counting, and it looks like right there could be a nice spot to stop counting. So here we go. Now, as I think to do my rise first, it looks like I'm going to go down. I got to go down, you know what I mean? So down 1, and going down is a negative direction. So my rise is negative 1, and then my run is to the right, 1, 2, 3. So that's positive 3. And so my m equals, let's see, negative 1 over a positive 3. That's going to be a negative slope of negative 1/3. Because this fraction does not divide cleanly. It doesn't reduce either. So my slope fraction just ends up being negative 1/3. A couple more examples like this. Let's see. No. That looks good as a nice intersection, and that looks good. So here we go. Looks like I'm going to rise up 1, 2, 3, 4, 5 spaces. So going up is positive. So 1, 2, 3, 4, 5. And then I'm going to go to the right, 1, 2, 3, which is also positive. So positive 5 over positive 3. That final answer is going to be positive, because a positive divided by a positive is positive. Can this divide cleanly, 5 over 3? No. Can it reduce? Can that fraction reduce? Nope. But I do know that my final answer is just going to be overall positive. So my final answer is 5/3 for my slope. Number 4, I see that as a nice spot, and I see that as a nice spot. So here we go. I'm going to start counting from here and go to here. Remember, my rise comes first, and it looks like I'm going to be going down 1, 2 spaces. So my rise is negative 2. Remember, it's rise over run. Negative 2, and then to the right 2. And so negative 2 divided by positive 2. Overall, that divides cleanly, and it's going to be negative 1. My overall slope is negative 1. Instead of counting, there is also a formula we can use to find the slope. This is especially helpful if you cannot graph the 2 points. Yes. This is a major formula. Okay, in fact, it's one of my big wall tattoos that I have, at least these days in the year 2018. And yes, this formula is what you use when what you are given is x1, oops, that looks too much like a comma, x1, comma, y1, and y, oops, idiot, x2, comma, y2. So if what you are given is 2 points, or what you know is 2 points, You know? Now, when it says it's especially helpful if you cannot graph, if someone gives you, like, look, we're about to do these examples where, sorry, a little bit of a weird typo kind of thing there, but anyway, if what you are given are two ordered pairs, the coordinates of 2 points, I mean, you can always get out some graph paper or sketch a pretty neat graph, I suppose, and plot the points and then count like we were counting here. That's always an option, right? But let's say especially if these 2 points were like real nasty, like decimals type stuff, 5.17 and negative 1.02. I mean, how are you going to graph those and then count? But also, what if this was like 507, comma, negative 102, and this was like 15, comma, 48. You know what I mean? Like sometimes you're given a couple of points that it's just not realistic to actually graph those and count. So that's what it's kind of saying when like a formula, just having a flat out formula is especially helpful if you can't really graph the 2 points that you're given. Maybe because the numbers are so big, you know what I mean? Like you wouldn't have a big enough piece of graph paper, or if the 2 points had like weird decimals going on. But this is the formula. And if you'll notice, still on white, this formula is just another sort of translation from the definition of slope equaling rise over run. Think about it. To figure out the rise, of course you're going to just subtract the 2 y coordinates. And to figure out the horizontal run kind of thing, of course you're going to subtract the 2 x coordinates. So this formula, it doesn't take too much brain power to kind of think about where this formula even comes from and why this formula makes sense and why it works. Okay? But so that's the formula. Even thinking ahead down the road to taking the Keystone exam, I wonder, well, this is the year 2018 where we have the Keystone exams. I wonder if these YouTube videos will outlast the Keystone exam, or which one will outlast which. So like, I guess I'm just wondering if you're watching this YouTube video in a year where you're thinking like, Keystone exams? What the heck are the Keystone exams? But anyway, thinking ahead to the Keystone exams, this is one of the formulas that should actually be given to you for free on your Keystone exam formula sheet, because it's used so often. Like here, this is my first point, so that's my x1, and that's my y1. And this is my x2, and that's my y2. And so for my formula, I'm going to do y2 minus y1. And already we see this like minus a negative situation. Remember, this minus, y sub 2 minus y sub 1, there's a minus built into the formula. And then y1 is negative 1. So yes, it's 4 minus a negative 1. And then on the bottom we do x2 minus x1, so that's 1 minus, and then x1 is 5. So again, just to double check here, y2 minus y1 goes on top, and then on the bottom we have, the x is x sub 2 minus x sub 1. And so that's what the formula is, and then we just let this play out. 4 minus a negative 1, that's the same as 4 plus 1. And on the bottom we have 1 minus 5, which is negative 4. And that's good enough for a final answer, unless you just want to like say, well, a positive divided by a negative, that makes the overall fraction negative, you know. A positive numerator divided by a negative denominator, that just, if you just want to bring that negative out in front, because that makes the entire fraction negative overall. Then it says, then plot the 2 points, just to double check your answer. Okay, 5 comma negative 1, that's right there. 1 comma 4, that's right there. Ooh, it just popped into my head that once people start to learn about slope and how it's rise over run, do not get that confused with plotting XY coordinates. Okay? Because remember, plotting 5, negative 1, I went over 5 and then down 1 because it was X coordinate and then Y coordinate. That's different than rise over run with the slope, okay? So, you know, I could connect these with a line technically, but just counting, we would go, let's see, down 1, 2, 3, 4, 5, over positive 1, 2, 3, 4. So it'd be a negative 5 over a positive 4, and so yeah, that holds true, okay? So here we go, one more example, I guess. Right, is it just one more example? Yeah, it is. So one more example. So again, this is our x1, that's our x2. You know, because remember it goes x comma y, x comma y. This is our first x and our first y. This is our second x and our second y. So the formula says y2 minus y1 on top. On the bottom we have x2 minus, and then looks like x1 is negative 2. And so we get that. Okay, so on top, negative 3 minus 4. Double check on your calculator if you have to, but negative 3 minus 4 is negative 7. And on the bottom we have what's the same as like negative 5 plus 2, which should get negative 3. And so is there any dividing clean? No. Is there any reducing? Only that there's no reducing, except we know that a negative divided by a negative is positive overall. So positive 7/3 as our final slope. And you know, let's plot these just to double check. Negative 2, remember, negative 2 comma 4. This isn't rise over run. This is plotting x and then y, left and then up. And then the other one is left 5 and then down 3. Again, for like the third time, to plot negative 5 comma negative 3, I go left and then down. That's different than slope being rise over run. And so yeah, we could connect this with a line, I suppose, if we, you know, might as well. And then counting the rise and the run, we go up 1, 2, 3, 4, 5, 6, 7. That's positive 7, and then a positive 1, 2, 3 to the right. And so that works out. And 7/3 is true. And that's it for section 4.1, really.